So we want to finish some ideas in Chapter 10 on simple experiments. So this will kind of highlight some things that are in the remainder of the reading that you need to do. But again, you still do need to do careful reading to get this material. So we had just, in the last part, talked about a couple of things you have to be careful about in designing experiments. One is selection effects, making sure you distribute your people in a way that they don't confound the groups at the very get-go. You have similar people in similar groups. And we said that, generally the easiest thing to do is you use random assignment. And that's for the between group studies. If you have a repeated measure studies, you don't have to worry about it. Now, aside from random assignment, if there's some variable that you're really concerned about and you don't want to just leave it up to random assignment to distribute those between your levels of the IB evenly, you can purposely distribute a variable evenly using that matched groups procedure. And your book explains that very well, so just go ahead and check it out there. But think about the reason behind it is so you can make sure that some variable that you know is important to the thing you're studying, but isn't your independent variable, you want to be absolutely sure it's controlled for. So you're going to go a little bit beyond random assignment and make sure the people on some variable are evenly spread out throughout your groups. All right, we also talked about design confounds. This is usually just called confounds, and that's when, again, something other than the independent variable is also different between your groups, like, the kind of pasta we served in those bowls, for example. I'll give you an example. I was running a memory demonstration in my class once, and for this, they get they're randomly assigned to one of two groups. And the first group goes out down the hallway, and I run the first group, and they have a certain set of instructions. And then we switch. Well, I was doing that in class one day, and during the second group, all of a sudden, while they were doing this memory thing, there was construction noise that started up outside the window. Well, that wasn't there for the first group. So here's something that was different between their testing environments. That wasn't my independent variable, but was a confound. It could have messed up their, concentration, their attention, their memory. And so that's the kind of thing that we researchers have to control for so that doesn't happen. Okay, so now in your reading, you're going to see, a section where it has like between groups designs, within groups designs, and it has a couple of different labels. I'm not horribly concerned that you can remember all those different labels, like pre-test, post-test, concurrent measures. There's some things that will come out naturally from that, but I'm not going to test you on those little specific things. We do want to spend some time talking about within groups, these repeated measures things, because it's great if you can do it. You need, fewer people. You control for those individual differences because they'll show up in every group. It's awesome. It's greater, better for your stats. But it does bring up some of its own issues that we have to be careful about in design. So if I have my people that are going to be, going through every level of my IB, I have to be careful, in particular, about order effects. Now that is, if you, let's say I have 3 conditions, and if I did everyone, they did the first task and the second and the third all in the same order, there might be something about doing the first task that kind of changes you. And so that when you get to task 2 and task 3, maybe you're better at the task because there's some practice effects. Maybe I'm doing a reaction time thing. And by the time you get to task 3, you're really good at this thing on the computer. Well, that's a confound, that practice effect, because you're better at the task than you were in condition 1. Think about a taste test. I'm going to have Coke, Pepsi, and some generic soda, right? And you're going to taste them. Well, if you taste Pepsi first, and you don't know it, but then you take the next soda, I could have changed your tongue. You could have been like, well, one's real sweet, and so relatively your taste buds are going to perceive this other soda differently than if you have switched the order. So to control for order effects, we will counterbalance. Not everyone's going to get Pepsi, Coke, generic Pepsi, Coke. Some people will get Coke, Pepsi, generic. Some will get generic Coke, Pepsi. Also, so there's an possible order effect. That in particular is called a carryover effect. If there's something that you really take from one condition to the next. So if you tasted Pepsi, and then you're going to go into condition 2 and you're going to taste Coke, there's still Pepsi on your tongue, you are actually carrying over something from the first condition into the second condition. And how would we control for that in a taste test? Well, usually if they really want to get good taste tests, they're going to have people like rinse and spit in between, so there's no literal carryover from one tasting condition to the next. But they are going to counterbalance, and they're going to give people a different order. Now let me show you how to do that real quick. If you have two conditions, let's say we have Coke and Pepsi, what are the possible orders you can do? Well, there's only two possible orders: Coke first, Pepsi second, or Pepsi first and Coke second. What if I have three conditions? I have Coke, Pepsi, and some generic soda. Well, I could go Coke, Pepsi, generic, Pepsi, Coke, generic, generic, Coke. It turns out there's actually 6 possible orders. Now, with 6 possible orders, I could probably run people through, anyone's going to get one of those orders, but I'll use them all. So that's called full counterbalancing. And to figure out how many orders there would be, what you do is you take the number of levels you have. So if I have 2 groups in my IV or 3 groups, let's say it's 3. What it is, if you can see this, it's called a factorial, I think. I don't remember from algebra in 9th grade. But 3, that means 1 times 2 times 3 equals 6 possible orders. If I had 2 levels, it would be 1 times 2. No, I'm sorry. Yeah, 2 possible orders. If I had 4, it'd be 1 times 2 times 3 times 4. I'd have 24 possible orders. If I had 5, it'd be 5 times 24. It'd be 1 times 2 times 3 times. It's like 5 times 24, 130 possible orders. Okay, so as you add conditions to your study that you want to run people through all of them, you kind of blow up with these possible orders. So you might do what's called partial counterbalancing. And let's say, there was a study at UT, some grad student was running it. There were 16 conditions or tasks that they ran their people through. Well, 1 times 2, that's like thousands of possible orders. So what they probably did was partial counterbalancing, where out of all the possible orders, the computer can set up, randomly gives you an order. So you're going to get, some of the possible orders. The fact that they're randomly picked is one way to control for order effects. Practice effects are things, if you have that being an issue, to control for it, people just let their participants practice the task for a while so they get up to some kind of steady baseline on, all right, I'm competent now. Now you can start collecting your data in your different conditions. So that's a control for that. All right, let me see, what else? Types of designs. Okay, so just in this third part, the last thing we want to kind of look at is interrogating our 4 big validities. I guess I'm not going to write these down right now, but remember, construct validity. So in experiments, construct validity. How did you measure your variables? And that would be your dependent variable. How did you measure it? Also, how did you manipulate your dependent variable? Was it a good manipulation? We mentioned this a long time ago. This is a place where researchers can decide if I'm interested in how a delay affects your memory. I'm probably going to, you can, your quiz, there's an example where there's a 2-minute delay, a 5-minute delay, a 10-minute delay. Okay, those are different enough from each other. You'll probably measure something. But if I had a group that had a 2-minute delay and a group that had a 2-minute and 10-second delay and a group that had 2 minutes and 20 seconds delay, that's not a very good manipulation. I'm probably not going to see any kind of difference in their memory and their recall of words with something that small. So construct validity for the IV could be like, did I do a good job of manipulating it? Another example, in that memory demo I do, I give people different instructions. It's supposed to trigger different kinds of memory systems, or it's different kinds of cognitive processing. The question there for construct validity is, do the instructions trigger my participants to do what I hope cognitively they're doing? I need to be careful about what I write and how I tell them their task so it actually does what I want it to do. Another issue with construct validity, look in your book on this. It talks about, okay, that experiment where the guy was testing color, red, green, or black, printed color number, and how did that affect the participants' performance on these problems? And he wants to relate that back to a theory about approach and avoidance of academic work. So the question is that a good test? That little funny thing about, does that really relate to his theory? And that's kind of a bigger question, but it does fall under construct validity. Are you getting at what the variables that you really think you're getting at? All right, External validity, again, pretty the same across all kinds of designs. I've got my 60 people, my 30 people, whatever, in my little study. Who do they represent? Okay. Do they represent all college students? It's the same questions with external validity. Now, with an experiment, though, what we can add to that is, all right, so I ran an experiment where people came in and they did a little computer test. How does that relate to the real world test? Or if I do this, memory test where there's this delay, how does that relate to people trying to remember material for an exam when they study? It has to go from the lab situation to what's actually happening when people behave in real life. And so there's a question of external validity there. Does it translate to how we really live? Okay? If I do a Coke and Pepsi taste test, how does that translate to how people purchase it? Does taste matter? Does price matter? So it may have limited external validity if people don't choose on price or taste. Of course, a lot of us do. And we go, oh, I like Coke better. And we're pretty brand loyal, aren't we? Okay, statistical validity. Something new comes up in this chapter with experiments, and that's Cohen's d. And you'll read about it, and it talks about effect size. Things can be statistically significant, but be small effects. When you see these studies about thousands and thousands of standardized tests, and one group does significantly better on an IQ test or an SAT test, it could be like a couple of points better. It's like a couple of points, big deal, a couple of points. Now, it is a big deal if these, in these large samples, that consistent, reliable couple of point difference is reflecting some systematic thing that's disadvantaging one group over the other, and that's something we could work on and change. Great. But when you look at an individual and go, well, statistically, you're probably a couple points higher, a couple points lower, just because, what kind of real difference is that going to make in that person's college application or something? So statistical and experiments, we can look at Cohen's d. It's a whole other calculation that people have to go through with their data to produce it. But it does give you a sense of how big a deal is that? If I give a memory test and I get a significant difference, but it's like a 1 or 2 word difference between the group, that's probably a small effect. But if it's like a 10 word difference between the groups, well, that's a big effect, okay, big impact. So read about that. And then internal validity, that has everything to do with controlling for confounds, controlling for these problems that we talked about. And what we're going to get into now in the next chapter, chapter 11, it talks about threats to internal validity. This is essentially all of the things that could happen to screw up an experiment. And this is going to be a big deal. So we're going to spend some real time on this, and we're going to get in the next video all of the things you could do to just really screw up an experiment and have crappy data and draw conclusions that make no sense at all. And when you can understand how to mess up, then you're going to appreciate what a really nice experiment looks like. So that'll be next in chapter 11.